Hello, good morning, friends. This is Coach Time here. Today we are going to start our new playlist. About the Coach Time, after a long time, and since I was busy in another work, if you don't know Coach Time, just simply click on YouTube. Simply search Coach Time here. Here is our channel. If you don't know what Coach Time do, so please watch this introduction to Coach Time. Here you will understand the brief introduction about what post time do. So, um, so in this channel we are going to see about the different technologies. Means we are uploading different best courses according to various branches and many more students. These are our playlist. So React.js, Java, Python, and our current subscribers are 680. Our next subscribers goal is 700. So we are going to upload the all one and two videos of all the playlist. Today we are going to start our new playlist because there are many students who are recommending about the subjects and topics of engineering level, that is operating systems. Let's go to our folder main study. These are our different courses we are going to cover in upcoming days. That is C programming, C++ programming, database, data structures using C, data structures using C++. Python is going to cover in the daily run Python, which is the Python programming with DSA. We are also going to cover about the Git versus GitHub, different technologies. Today we are going to cover about operating system. So starting from this, we have total 28 modules about that divided the operating system in 28 modules that we are going to see in this class. We have created a folder today's class where we can upload today's date, that is 1 June 23. So there are images so we can understand easily. I will upload this folder updated daily on Google Drive, and I will share the link in the description box of this video. So starting from the operating system here, operating system means operating system simply means which means the user interface we are going to see on the desktop, that is operating system. That means the on which system that operates. Okay. Uh, so, Simply there are modules like operating system basics. That is, means there are different operating systems available in the market like Linux, Ubuntu, Windows, and many more. In the today class, we saved one image. Let's simply open with the Paint. Open with Paint. Okay. So starting from the operating system basis, we simply discuss this. Then we will discuss about the process and threads. Processes are basically the programs that are dispatched from ready state and are scheduled. Schedules means job scheduling or disk scheduling means we schedule different jobs about the memory management and this central processing unit. In the Simply we use it, that is scheduled in the CPU for execution, that is PCB, that is process control block. This is the process control block means different, like if this is a block, there are different many processes are available in this block. uh, Holds the concept of process. This holds the concept of process. A process can create other processes which are known as child processes. For example, if we discuss, for example, this is the one, and this is the two, and this is the end process, and this is the end process, and this is the n minus one process. So if we create different processes, means like this is the child process of sub process, it is called child process. So here we get another, like 1 plus 1 1n 2n, or this is means different, we get m. This is the m minus 1. Again we distribute this m minus 1 in different processes like block. This is the process control block. Okay, this is another processes. These are called child processes. So a process takes more time to terminate, and it's isolated means it does not share the memory with any other process. For example, this line discusses about the if we terminate at the time of the process, like a process takes more time to terminate, it is isolated means it does not share the memory with other process. Because if this is the child process of this main parent folder, like this is the parent process, this is the sub-parent process, this is the child of the sub-parent process. If we going to terminate this, like if we going to terminate this process, it is connected to its sub-parent process. So it takes time. If it is takes time, this is if we also going to uh, terminate the sub-parent process, it also takes time because it is connected to the parent folder. There might be in background music, there must be a splits avoid it. So the processes can have the following states like new, ready, running, waiting, terminated, or suspended. Like it's categorized in these types. For example, if a new process is created, like this is the new process is created, this is the new state, like it is the basic new state of the processes. Then again, there must be a ready state or running state, running processes. So after the child process of this parent process, this is the running processes of the parent process. And again, if we add some threads or processes or terms in this second parent folder, then this process cannot be run because it is in the waiting state. So there must, if we terminate this, there will terminate processes or suspended background noise may be muted. So we are discussing about the processes, that means the fourth point, the processes can have falling states like new, ready, running states. So we have discussed this. So again, threads. Thread is a segment of a process. If we classify this, for example, uh, simply we take a new. Uh, for example, this is a process. For example, just simply avoid the drawing. Then if we, and this is the processes. Okay. So if we in that we discuss about the discuss about this is the sub process sub process. If we simply uh, create an another in the, like it is not a sub process. For example, if you take a mini process or a segment of this a single process, that is called a thread. For example, if this we are going to take, okay, this is called a thread. Like threads includes means there are different many threads regarding, means like threads have different processes, or simply like if we have dogs, threads and processes. Like if we go to images, so this is about the thread, like code data points. These are different threads like stack counter. For example, it has stacks. For example, this is the stack code data, different processes, like this is threads. Okay. uh, if we simply say to 4, This is the discussion about the processes and the threads. CPU scheduling, that is central processing unit scheduling of the jobs. Like CPU provides a different jobs about different processes. If we simply open the second image, simply open with the paint. So scheduling is the process of arranging, controlling, and optimizing work and workloads in the production of a process or manufacturing of the process. For example, this is the process divided into different uh, segments. Okay, simply avoid the drawing. Okay, scheduling is the process of arranging and controlling and optimizing. Arranging. So here we understand the arranging of means like this is the CPU and this is the process. Like arranging of this process, like arranging of this fragments, like threads. This is the, for example, thread one, like thread one, mm, thread one. What is this? Okay, thread one, thread two. If we classify or arranging these different threads, it's called scheduling of the processes. Then again, we control these threads and processes and optimizing work and workload in the production process or manufacturing processes. Scheduling is used to allocate plant and machinery resources, plan human resources, plan production processes, and purchase materials. So this is the discussion about the scheduling. Then we will discuss about the next topic, that is process synchronization. Process synchronization is the coordination of execution of multiple processes in a multi-process system to ensure about. Simply, we will discuss this in the new slide. So please select this, copy this, save in new, paste. Okay. Because we will simply using the diagrams. Process synchron is the coordination of execution of multiple processes and a multi-process system to ensure that they access shared resources in control and predictable manner. So this is the processes. Means synchronization is basically about the execution of multiple processes. Like this is the single parent process, there are many more multiple processes are going like in the background. So this is the synchronous coordination. For example, coordination of these many more processes. Okay, coordination of different many more processes. It aims to resolve the problem of race conditions and other synchronous, because there are many processes are running in background. So there must be a delay or a race conditions, like which process is going to complete or suspend or terminate. That is the states of that processes. So it's simply race conditions and other synchronization issues in concurrent system. So the main objective of the process synchronization is to ensure that multiple processes access shared resources with interfacing with each other. Like if we draw a simple line, like this process is simply, so this process is ensure multi-process and it is the shared resources. Shared, like these are the multiple processes, but shared resource. This is the shared resources across the multiple processes. Okay, simply we will place in the middle of this uh, shared resource. Okay, okay. Then means like shared resource without interfering with each other. Like there is no interference between this. These are the only shared memories. Like there means this is there is no interference between these. This is no interference between these two. This is no interference between these two. But only there are shared memory, shared resources. To achieve this, various synchronization techniques such as semaphores, monitors, and critical sections are used. In the multiprocess system, synchronization is necessary to ensure data consistency uh, and integrity to avoid the risk of deadlocks and other synchronization problems. Processes synchronization is an important aspect of modern operating system. It plays a crucial role in ensuring the correct and efficient functioning of multiprocess system. On the basis of synchronization, processes are categorized on the following of two types, that is independent process or cooperative process. The independent process discusses about the execution of one processes does not affect the execution of the process. If this is the process is going in the current state or running in the current state, it does not interfere with the another processes. Like the execution of the one process does not affect the execution of other process. If the process is completed, because the shared memory, shared resources is across the multiple processes, it does not affect another processes, that is called independent processes. Then cooperative processes, a process that can affect or be affected by other processes executing in the system. Like if we take these three processes, because on the completion of one, there must be effect on another processes, and this on the second process, there must be an effect on the other process. This is called cooperative processes. Then again, a process synchronization problems arise in the case of cooperative processes, and because resources are shared on cooperative processes. So here is our point. So we discussed about the process synchronization. Then our next modules is deadlocks, memory management, disk scheduling. So simply deadlock is defined as simply we are going to open with paint. So here is the deadlock. Simply a deadlock, like this is the workflow of the OS, like deadlock, memory management, disk scheduling. So deadlock is situation in which two computer programs shared same resources are efficiently. Like for example, these are the two computer programs, but they shared same they sharing the same resources that are like this. Okay, preventing each like the same resource are effectively preventing each other processes accessing the resources, resulting in the both programs ceasing to function. The earliest computer operating systems ran only one program at a time. Like the operating system is both programs ceasing to function. The earliest computer operating system get only one program at a time. Like this is the on the earliest computers only one program run at a time. So here deadlock is covered. Then is memory management, disk management, or disk scheduling. We simply cut this out. Disk management of the operating system. Disk management simply Simply, for example, this is the disk management on operating includes, for example, this is the disk management with across a form. So there must be a disk format. For example, if there are different disks, it is the one disk, two disk, disk number three, and disk number n. If we formatting the disk, there are different operations. If you disk formatting, for example, if you format the disk, okay, this must be formatted. Then if we restart or booting the disk, that is restart the disk. What is this language? Okay, restart. So there must be another bad booting, booting of the disk. Okay, bad block recovery. For example, this include in restart, this in restart. This disk is used in booting. This disk is used in bad block recovery. Okay. So this is the about the disk management of the operating system. So this scheduling is also known as then our next topic is this scheduling is also known as IO scheduling, that is input output scheduling. Disk scheduling is important because multiple IO requests may arise in different processes. That is, multiple requests are accessed in disk. In different processes, only one IO request can be served at a time by the disk controller. Thus, other IO requests need to wait in the waiting queue and need to be scheduled. Two or more requests may be far from each other, so can result in greater disk arm movement. Hard drives are one of the slowest parts of the computer system, thus need to be accessed in an efficient manner. There are many disk scheduling algorithms, but before discussing them, let's have a quick look at some of the important terms like seek time, that is delay time, or rotational latency, or transfer time. So, so like seek time, rotational latency, transfer. Seek time is the time taken to locate the disk arm to specify track where the data is to row, read, or write. So the disk scheduling algorithm that gives minimum average seek time is better. Then rotational latency. Rotational latency is the time taken by the desired sector of the disk. For example, this is the sector of the disk. For example, this is the sector of the second disk. Uh, like sector disk to rotate in a position. For example, this is, for example, this is rotating in this direction in circular motion. Disks that rotate into a position that can access the read or write heads. For this moves in such a way that they can access read or write methods. So the disk scheduling algorithm that uses minimum rotational latency is better. So transfer time, that is read or write methods for from one disk to another disk. It's called the transfer time. Transfer time is the time to transfer the data. It depends on the rotating speed of the disk and number of bytes is to be transferred. This access time Disk access time is simply if we accessing the disk for that is first disk, so the time required is called disk access time. Then we access the second disk, then we access the third disk. So here we are discuss about the different modules of operating system. Then we are going to start OS basis in the upcoming lectures, simply basic structure of computer system. So in the OS basics, we discuss topics like introduction, types of operating system, function of need of operating system. So in the next lecture, we discuss these topics. So this is our course time channel. So please like this video, comment below. If you want any other courses, please comment below, like tagging the different courses. It means like we are going to cover about different playlists like study, C programming, C++ programming, database, DSA using C and C++, Python programming with DSA. Our next subscriber goal is 700 because we are going to cover different goals like 100 in the upcoming in multiple times like 100, 200, 300. So next subscriber goal is 700. On completing the 700 subscriber goal, we are going to upload different courses also, and this operating system will be uploaded today, that is 1 June. And we are going to also cover the daily run Python because only three to four lectures are covered. So we are going to practice the different Python upcoming algorithms and also. So uh, thank you and take care.